Okay, so let's take a look at question number 3. So in question 3 is a very interesting question. So it says that a 15 kg block B was suspended from a 2.5 meter cord attached to a 20 kg cart. So this is a 15 kg block B was suspended in 2.5 meter cord to a 20 kg accelerating cart. So using that friction, let's determine the acceleration of this cart and basically the tension in the cord immediately after the system was released from rest. So initially the system was released from rest in this position. So I release it. And what I want to find basically is the acceleration of the cart and the tension in the cord. See, look at the question. The question basically gives you a clue on what kind of formula you should use. It says acceleration. It says tension. What is acceleration? What is tension? What are the things that can form them together? Newton's second law. So in this case, when you see questions that ask you about acceleration, when you see questions that ask you about certain forces, you know you have to use Newton's second law to solve it. So how do we solve this question here? Now this question might seem complicated. So when you look at a question like this and you know you need to use Newton's second law, first thing you do all the time, first thing you do was to draw the free body diagram. From the free body diagram, you try to see how the forces interact with one another. And after you know how the forces interact, you basically can map out the kinetics of the object itself. So first of all, let's take a look at what is it called? Object A. Free body diagram of object A. So we just look at object A here. Now, object A is constrained to move in the horizontal motion, right? A cannot accelerate up and down. It can only accelerate horizontally. So let's look at what are the forces that act on A. So the force that act on A is apparently its weight, which is mg, mass of A times G. And what? Normal force acting on what is it called? A, N. And also, the tension is pulling in this direction, so definitely there's a tension force here, P, which has an angle of 25 degrees. Now, that's the free body diagram of A. Now let's take a look at what are the formulas that form the free body diagram of A. First of all, we know that F, summation of F equals to FA. So what is the summation? The summation is normal force, 90 degrees, plus the weight of A, direction negative 90 degrees, and plus the tension force, this tension, pointing this direction here. Now, this direction here is actually 270 degrees minus 25 degrees. Right? This is 270 minus 25, so it's just basically 245 degrees. Okay? Now, this is the summation of forces. Is equals to the mass of A times the acceleration of A, which we know can only be constrained in this direction, so we should assume a direction, we just assume it's going to the right, so it's 0 degrees. Now, if the acceleration of A is pointing to the left, this AA will show as a negative value, so don't need to worry about that. Now, or if you want to do a bit of imagination, you can think that A is going to the left, so you can put 180 here. It doesn't matter. Okay? Now, that's from equation that we get from the free body diagram of A. So the next thing to do was basically to find the free body diagram of B. Now, for B, it's a circular sphere. For B itself, what are the forces acting on it? There's only two forces acting on it, right? There's only the vertical force, which is the weight, and the tension force, which is T. Now, what is this direction of T? So first of all, let's write the free body diagram equation. So this is equals to the tension. Now, what's the direction of the tension? It's just this direction, right? So you draw a vertical line here. This is 25. This is 90 degrees. So this is just equals to 90 minus 25. So it's 65 degrees. This is basically 65 degrees. Because 65 plus 25 is equals to 90. And 90 plus 90 is 180. Plus the weight, which is just MBG direction negative 90 degrees. Now, interestingly, what is the acceleration of B? Now, most of us will be tempted to say that B is going in a circular motion. But the truth is, you don't know. Why? Because first of all, A is not a fixed point. A might have a velocity of 0, but the acceleration is not 0. So it's impossible for us to know what is the acceleration of B. In this case, we should just say that summation of F equals to MA, and this is just equals to mass of B times acceleration of B. Well, acceleration of B is an unknown. We don't know what is the acceleration of B. You cannot possibly define the position or whatsoever. This is impossible. So how do I know this? First of all, if you want to say that it's a circular motion, A must be a fixed point, but A is not a fixed point. A is going to move. Although it's not moving, it's going to move. So the acceleration directly affects this idea. So we can only say the acceleration of B is an unknown. Now let's take a look at this. How many unknowns do we have? How many equations do we have? So first of all, we have two vector equations. So it means that we can solve 4 unknowns, right? For each vector equation, we can solve 2 unknowns. So let's see how many unknowns do we have. We have 1 unknown, which is n. The normal form is unknown. We have 2 unknowns, which is t. We have 3 unknowns, which is acceleration of A. And we have AB as an unknown. Does it mean we have 4 unknowns? We actually have 5 unknowns. Why is it so? Because this is an unknown, but this is 2 unknowns. We do not know the magnitude of AB. We also do not know the direction of AB. So in this case, there's 2 unknowns here. So we have 5 unknowns in total, but we only have 2 vector equations. So we still cannot solve this equation. So it means that we need one more information. Now see, look at that. We have already exhausted our kinetic option. In other words, we have utilized the Newton's second law. This equation for Newton's second law, this equation for Newton's second law. So we need to use one more equation, which is utilize our previous knowledge from kinematics. So how do we relate to kinematics? So first of all, we have A as an unknown, we have AB as an unknown. Is it possible for us to relate point A and point B? Of course it is. Because point A and point B is connected by the same body, which is the string. Since 2 points on the same body, we can use what equation to relate? We can say acceleration of A is equal to acceleration of A with respect to B plus acceleration of B. Right? According to some manipulation, you can say AB is equal to acceleration of A minus acceleration of A with respect to B. Now here's the interesting part. What is acceleration of A? Acceleration of A is just this term, right? It's just acceleration of A, direction 180 degrees. Now what is acceleration of A in B perspective? Acceleration of A in B perspective. Now this is tricky because we don't really know. However, in B perspective, A is a circular motion. So first of all, we just need to find the omega of the string, and we need to find the angular acceleration. But what is the omega? Now, this is the interesting question here. This is a very special case. In this case, you are releasing from rest. When you are releasing from rest, apparently this body here has no angular velocity because it's instantaneously at rest. All points on this string has a velocity of 0. In other words, this string has an omega of 0. So acceleration of A with respect to B is a circular motion, but there is 0 centripetal acceleration because omega A B is 0. So acceleration of A with respect to B only have tangential acceleration. So just put it in terms of alpha RA. The direction, tangential acceleration, assuming alpha is counterclockwise, is equal to position angle plus 90. The position angle is equal to 65 degrees, plus 90 is 155 degrees. This is a tangential acceleration. And let me repeat, there is literally no centripetal component because omega is 0. Okay? I hope we can look at this. Okay, now after we wrote all this thing, let's take a look at what we have. So first of all, we establish a new equation. When we establish a new equation, what I can do is this is what I like to do usually. So after I establish the new equation, I would like to substitute back the term where I have both unknown magnitude and direction. In this case, the only term with no known direction and magnitude is AB. Right? AB, I don't know the direction, I don't know the magnitude. But I can represent AB in this form. So what I do is immediately I substitute this into here. I put this whole thing inside here. So if I do some manipulation, and I cancel this thing, I sub this into here, what I get is actually this is equals to AA, direction 180 degrees, minus alpha RAB, direction around 55 degrees. So since I already substitute this equation inside here, I can basically ignore this equation anymore because I have already included the terms inside here. So let's take a look and check. What are my current unknowns? My current unknown, based on both this equation, is the normal force, M, tension, T, acceleration A magnitude, and alpha. Right? RAB is not an unknown because RAB is basically just a distance from A to B, which you can find it mathematically. So, look at that. We have four unknowns and two vectorial equations. We can solve this equation. Oh yeah, sorry, the mass. Yeah. Thanks. Mass times this. This is the acceleration. So summation of force is equal to mass times acceleration. Sorry. Yeah. Thank you. Yes. And this mass is actually the mass of BR and B. Okay? Now, look at that. Now I'm gonna, so sometimes it's hard for us to do this. So in the exam, when you reach this step, what you do is just basically resolve this into I and J components, resolve this into I and J components, and do simultaneous equation. Now it's going to be very complicated, so personally I like to introduce another method. I would like you to use a combination of both simultaneous equation and dot product method. So in this question, what they are actually interested is only two equations, two objects. They are only interested in the value of T and the value of A. Yeah. They are only interested in these two values. So we only have to achieve these two values and we are happy. So let's take a look. We need to eliminate N and alpha. That's our main purpose. So let's take a look at this equation. Since I don't need anything about N, what I can do is that I can just dot product with a number that will eliminate N, right? So I just dot product with 0 degrees. And I create an equation with without N. So if I dot product with 0 degrees, let's do it here. If I dot product with 0 degrees, I will get T cos 245 is equals to negative MA. And first equation. T cos 245 is equals to negative MA. That's the first equation. I dot product with 0 degrees to eliminate N. Why do I eliminate N? Because I don't need to know anything about N. The question doesn't ask me to find N. I need to find tension and acceleration A, that's all. Now, for this equation here, I'm not interested in finding alpha. Because the question doesn't ask me to find alpha. So what I do is that I dot product with a number, then my minus with 155 will get 90 degrees. So I dot product with 254. Right? 254 minus 90 is equal to 155. If I dot product with 254, I get T cos, let me see, 65, so which is 180, plus MBG cos 335 is equals to MBAA cos 180 minus 245 is just equal to 65 degrees. This is my second equation. My first equation and my second equation. Now take a look. My first equation contains only two unknowns, tension and AA. My second equation also contains only two unknowns, tension and AA. I just have to do a simultaneous equation of this equation and this equation to get my T and AA instead of doing a four unknown simultaneous equation. So what is the takeaway here? The takeaway here is that, first of all, I can actually simplify these two factorial equations so that I don't have to find four unknowns. Because the question only wants me to find two unknowns, right? Tension and acceleration of A. If I were to resolve everything to I and J and I and J, I would need to solve for four unknowns, which is very tedious. So the trick here was to use dot product to eliminate the unknowns that I don't need to find. In this case, I eliminate N. I eliminate alpha. Now sometimes it's not that simple to see. So when it's not so simple to see, usually there's another trick to look, there's another way to look at this thing. How do you know which terms to eliminate? Now one of the methods was to see, first of all, look at which term you donate. And if those terms only exist in one of the equations, you can dot product them. Look at this equation. I don't need n, I don't need alpha. But the normal force n only occurs in this equation. And it doesn't occur in this equation. So you don't need to bother about it, just dot product to get n out. And the alpha only exists in this equation. So I dot product angle that will cancel alpha. And eventually got an equation that is clean of alpha and n. And simultaneous term give you the answer. So, yeah, that's right. So that's how you do it. So the simultaneous term, and you get t and expression of a in this manner, which is much simpler than just simultaneous equation of 4 equations. That's all. So we'll go to the next question.